Um, Hi. So for this M3 final hackathon, um, I'm developing a regressor that minimize the uh mean absolute error when predicting average daily household electricity consumption using the dataset um in the cargo. So I begin with a carefully data cleaning since the dataset includes some special survey codes such as -1, -2, and -9. Um, these are representing don't know, not collectible or missing values, which described in the prompt. So I replace all of them with the missing values so they could be handled appropriately through the imputation. This prevents the model from misinterpreting those codes as a meaningful numerical information. So next, I built a pre-processing pipeline. I separated the numerical and categorical features to treat them properly. For numerical variables, I applied median imputation to handle missing values. So for categorical variables such as region and divisions, I used most frequent imputation to followed by one hard encoding. I manipulated all pre-processing steps with the column transformer and pipeline framework. These approaches ensure that all transformations are applied constantly and avoid data leakage. Next, for the regression model, I select the histogram booster regressor instead of a simple linear regression model because electricity consumption highly depends on many non-linear factors such as square footage, household size, heating equipment, and geographical location. So a tree-based boosting model is more suitable for capturing complex relationships. Besides, and turnkey high parameters such as the learning rate, maximum depth, and minimum samples per leaf to balance the flexibility and the um, regularization. Um, After this step, my validation MAE is approximately 9.17, which um, become a little bit stronger in the predictive performance. Okay, so let's have a look of my code. Um, so here is import, um, replacement, regressions, and train the mode. Then I make the learning curve. So for the learning curve, this is because I want to assess and improve my model fit. So I use the training validation split to evaluate out of sample performance and generate a five-fold cross-validation learning curve. This learning curve plots training MAE and cross-validation MAE as the training size increase. From the plot, I found that the training I found that the training error gradually increased while validation error slightly decreased and stabilized. The gap between the two curves were moderate, which suggesting that the model is not severely overfitting. At the same time, validation error was not excessively high, which indicates that the model is not underfitting. So, um, these two conclusion means that the learning curve shows a reasonable bias variance balance and confirms that the model generates pretty well. Um, in conclusion, I improved the model performance through the proper data cleaning, structured pre-processing, appropriate model selection, and the hyperparameter turning aligned with the MAE objective. I also improved the model fitting used the validation MAE and a cross-validate learning curve to diagnose bias and variance. By all of these steps, I think I built a well-fitted regressor for predicting household electricity consumption in this project.